What we have here is, I guess it's a crankcase cover from a 1937 Harley Davidson. I guess it's a Flathead engine. I'm not really sure of the models. This is the outside of it. Yeah, 37W, so it's a 1937. This was brought down the road from my neighbor's shop that does the Harley Davidson stuff. Does all antique and classic and vintage Harley Davidson. The task that he asked me to do, bore this bearing journal out to remove that reduced section. If I flip it around, you see it's a reduced area. And what this is essentially is the old seal, quote unquote, from the original configuration. It's a slinger type. It's got like a thread in there, if you can kind of see that. And he wants me to bore it out to within a half thou or so of this nominal bore. We're not supposed to touch this at all. In fact, it's like part scrapping event if I do. He's going to end up honing that in by hand. But we also have to cut a snap ring groove for a snap ring like this that's going to hold a seal.
Holding a seal is actually inaccurate. It doesn't hold the seal in. It's just a backup, he said. Just insurance to make sure the seal stays in place because there's no pressure behind it.
This is what I have to base it off of, is a later model. I have two of these, by the way, to do. There's one to your right out of shot. Let me show you the part we're basing this off of. This is a 1946 engine crankcase cover, 46 WL. You can see on this one, the bore is all the same diameter all the way out to this little lip. And then there is a snap ring groove right there. Now that snap ring groove is full of rust and crap right now. So I haven't been able to measure the OD of that groove because we need to match that for the snap ring here, for this one. I don't have a machinery handbook, which I really absolutely need to get because I could actually look that up. I could look up this snap ring based on the size, and then it would tell me in the machinery handbook what the standard or other types of tolerance grooves would be to hold that in place, snap ring groove. But we're just going to duplicate this one. Now the dimensions between the two sides as far as the thickness of that bearing journal are different. It just has to have a snap ring groove put in these as close to the outer edge once it's bored out as possible because it's a rather thick seal, he said. On this side, I called him this morning actually about this and I said, let me get a pointer here. Pointer sisters. I'm so excited. Okay, so I am concerned about the little holes here, and I said, what are those 3 holes for? Was this originally screwed into the cover? He said, no, it's cast into the cover. He said, that's a debate that's been going on forever. Nobody really knows. He said, my assumption is Harley used it to fixture or hold this steel center section in the form, if you will, when they cast this aluminum around it. So that makes sense. They only go in a little bit. I haven't measured them yet. I'd say maybe 3/16 of an inch, maybe 200 thou, something like that. And what's going to happen is when the snap ring is in place, we'll just lay it up here for now, that groove is going to cut into these, I would call them like pin wrench holes. So I'm just going to call them pinholes. It's going to extend into these pinholes. And he said he understands that's no problem. It is a little bit of a challenge for me because I'm going to be cutting in a groove, a snap ring groove, in an interrupted cut. And I don't know how that's going to work out. I'll tell you about the tool we're going to use here in a second. And so as far as, it's pretty standard operation as far as the machining goes. The fixturing is another matter because it's a rather big diameter part, certainly not round. There's no way it's going to fit in a 4-jaw. So I had to pull something out that I've never pulled out before. No, not that. I've used that before.
That's bullshit.
And I will show you that now, how we're going to do this. And yes, what I did was I pulled the faceplate that came with this lathe. It's a D1-4, camlock faceplate. I've never taken it out before the bag. It had all that cosmoline-like schmoo all over it. And I cleaned it all off and I stoned both sides. Stoned, dude. Because I had to kind of work the problem yesterday and I wasn't sure what I was going to do, so I did not turn the camera on for that. So I'm going to reproduce what I did yesterday to show you how I'm going to fixture this, the process of leading up to, doing the modifications on this, which is ultimately what we're going to do. We're going to modify this backing plate, a tool we can use in the future for the same thing, because I'm pretty sure, and I talked to him about it this morning, he said there'll be more of these to come in the future. I said, yeah, that's why I'm trying to set up a repeatable fixturing setup for this. I need to back you up just a little bit here because we are just a little tight. The best way to fixture this for access for that bore would be this way. So I can actually see the bore and I can indicate the bore in, not only indicate it in concentrically, but parallelly. I just made up another word, I love it. I need to make sure that the parallelism is spot on. So in other words, in and out of that bore and also concentric to the spindle. So this would be a great way to do it, and pick up on this back here like with some sort of a spacer, clamp it somehow, building some stanchions that came out. These are all different heights. The more I looked at that, the more I said, that is stupid. This is a machined surface because it mates to the crankcase. We know this is a good reference surface. Now if we simply spin this around and put it up against the faceplate, there are a number of holes that fall within the outside diameter of the faceplate. And that way we can mark those, drill and tap them over on the mill, and then we'll be able to bolt this thing up. The challenge is I need to have some flexibility so I can move this around. And so I can dial this in and get it as true as possible. But I need to get this really close. And I don't have any way to stick something into this bore here, which is just under 2.5 inches diameter. Bring it out so I can actually see something and line it up. I don't have a piece of material, otherwise I'd have banged one out yesterday with the 3-jaw that would have just slipped in there, and lined it up and been done with it. So I need to get this center of this cover, which I can't see the inside of it very well, concentric with the backing plate, the center of the backing plate, as much as possible. So I do have enough wiggle room once I put this on and use bolts that are going to be smaller than these holes, so I can move it back and forth on the backing plate and then cinch it, bolt it down, tighten it, and then we got a really good purchase. And that would be the best way to do it. But I have to get it close to start off with. That's the whole thing. If I'm off significantly, then I got a hole that's off. I'd have to redo them all because you're not going to be able to move one hole. I don't want to do that. So I figured the best way to do this would be to find something that you put inside between two centers. For example, this, I believe that is a 7M GTE Toyota Supra wrist pin. Piston wrist pin, if I'm not mistaken. That's one of the old ones left over. I use these for various things. A little closer. I need to bring the carriage way up here. Lock the tailstock and give this live center a really good push. So now this wrist pin is most definitely straight between those two centers. It has to be. The tailstock is in pretty good alignment with the headstock, with the spindle. Considering our hole is not different diameter and it's concentric with the outside of this pin. We know that that's in the right place. But there is a caveat. This is not a tight fit.
Fits like a cock in a shirt sleeve.
So I said, well, we can make it a tight fit. Let me let this find its heavy spot so I can kind of go over here. I found a piece of aluminum pop can in my shim stock from one of my pop cans that I think it was a kombucha can actually. Dr. D's helps you shit in the morning. You work it in there, it's just got a little bit of clearance. Shim that space between that pin and this case. And now it's much snugger. It's probably 20 thou movement, close enough. I took the bolt out on that case that I was working on, and I will take it on this one too. And I lined it up to a space in the back here where you have one of the slots. That way I can put one of my T-slot from my small mill fixturing outfits through here and then use a nut on that one, because there's nothing on this side to hold it. These bolts are too far offset. I guess that's for the cylinder, the two cylinders rather. This is the cylinder base right there. We go back around, let's turn the whole thing. We go back around, we've got 1, 2, 3, 4 that do fall within the outside diameter. And then again, this one right here. And that, let me go ahead and pull you back. I'll bring you back up. That is what these represent. 2 holes here, 2 holes there, and then wherever that is as far as one of the slots, I don't know. It will line up to a slot. These work perfect in my small mill clamping kit. I mean, they go right, they're like designed for these T-slots. I couldn't believe how good they were. Drops in there, goes through, we'll just nip them up just lightly. Bob's your uncle, that'll be good. I got plenty of M6 hardware. Smaller diameter than those clearance holes, which I think are for 1/4 inch, looks like, in that case. Remember, this is all Imperial. It is, you know, antique Harley. We're gonna be able to have some wiggle room. That's the whole thing here. We gotta have a little bit of wiggle room to move this around. Get it dead nuts. Now, speaking of dead nuts, I did indicate this bore yesterday, just for shits and giggles, basically. It's within a 1/2 thou concentric. But what I have not done yet is indicated the face. So we're going to do that now and make sure this thing is not running out, because if it is running out, we're going to have to skim cut it. Before we do that, we're going to have to do the holes, because I don't want to lose my hole markings. But let's just see what it is right now. There you go. I got you on the headstock now, so I think that'll be better for you. All right, so let's see what we got. Oh, you think? Think we got a little problem here? McFly, hello. 12, 14 thou. Yeah, that's completely unacceptable for what we got to do here. Once we do the holes, because I need those in first, I can't lose my markings. That was too much of a pain in the ass to do. We will just skim it, because they're going to be through holes anyway. Who cares? All right, we're all set up here. Let me turn the thing on. You know, it occurred to me I never actually showed you guys the new light setup on the quill of the milling machine. Let me show you that real quick, because I never got to it. What this is it's a halo light, a 12-volt halo light that you can get for cars, you know, to accentuate the lights. I mounted it up on the bottom of the quill there and just made this cover. What this cover does, it just gets held in with a spring on the back side here. With that, it's just made out of some aluminum flashing with a little trim piece, you know, so I don't cut my delicate fingers. Keeps it shielded from the side because it's so bright that it actually washes out your view. And you just want the light to go down on the workpiece. And as far as the power goes, it was from the round column mill group on Facebook that I got the idea. And it's just adhesive tape holding it in. But anyway, the guy on the round column mill group bought some cheapo, you know, 12-volt AC to 12-volt DC output converters. But that puts out 12 volts DC, which is what powers the RPM, that display. So I just tapped into that. So when this thing turns on, the light turns on because it's, you know, off the same 12-volt source. You know, it's going to be quicker. I'm just going to use the SDM function on the DRO. And there's another video where I show you this. It's the whole reason why there's no vise on the milling machine right now. The vise is over here in that clutter. I don't know which one will come out first, this one or that one. But we're working on a KZ1000 cylinder head. This is from a police bike, 1983. This was shipped in. I had to do a crap ton of thread repair on the other side, or the cam caps. Hold down the cams. On this side here, you see? And I also made one ginormous, like heart-stopping error. Going to be in that video. That is like a part scrapping error, but I managed to figure my way out of it. But that's why this is all set up that way, in case you were wondering, and why we're using the SDM function, because I used that function to do all that locating on those holes. So SDM, that's sub-data memory again, okay? So what this is used for, when you have multiple holes and you have to do multiple operations on them, it's quicker, instead of doing one hole and 3 or 4 tool changes per hole, to just use the SDM function. And it just takes a minute or two to set up your, in this case it'll be 4 SDM locations, and then just move around to them based on the DRO. So once you set them, you just move around 1, 2, 3, 4, and then it'll be exactly in that same spot for that particular hole. And so I'll go ahead and do that. I'm not going to show you that on camera because I show you it in very great detail on the cylinder head video. I had one of my holes off. I don't know why I marked it over here somewhere. That was wrong. The punch mark I used a drill actually, go up in there and just tap it. The drill that fit the hole pretty closely, just about 1/4 inch. It was actually up there, and that makes sense because I thought all of them were on one side. That's why I was going to pick up that one through hole with a T-bolt opposite it to clamp this side down. So that was a mistake, but I didn't drill the hole. I noticed it and then just moved it over. So that's subdatum 3. So 1, 2, 3, 4. So all you do is 0 out on that SDM. And so since we're on 4, we'll go ahead and start with that. This is one of the situations that I do use anchor lube. Otherwise, I really don't like this stuff. Doesn't really do much. Absolutely green shit snot. Toggle over to 3. And so on, and so on, and so on. We'll get that face sorted out as far as it being out of square and make that nice and true. Then we can bolt up a case and at least start the boring operation. Grooving I can't do right now because I ordered a special grooving tool, a carbide grooving tool, which is going to be a little tricky because it's going to end up being an interrupted cut. I think I explained that before. So it's yeah, it's going to be a little bit of a crapshoot, and I do not know how hard that steel is that they used on that. I imagine they didn't use too terribly hard steel. So let me get the locking pins back in and get this all cleaned up, and then we'll put it back in the lathe and do that, at least that facing operation. Well, I'm not entirely sure what happened, but I did clean the back side of that with some brake clean. You know, where the taper is, it goes into the spindle nose. And now it's only like 0.003 off. But it is high in one particular spot. I'm going to skim it anyway. There's no reason not to. But it's a hell of a lot less to take off, which is nice. There's no zero marking on this faceplate, so there will be when I get done with skimming it. Then it'll go back in the exact same way every time, and it should be repeatable. Okay, I had to angle the compound rest around to about 35 degrees so I can get the travel. I'm going to run from the inside out. Tested it at 600 RPM and it's a no bueno. This son of a bitch is out of balance rather, just like the Ford jaw. So we're going to end up having to do that balancing thing on this thing sometime in the future. But I can run it at 360. Now, when we put the part on, who knows how? It may balance itself out. We can run a little faster. I don't know what speed we're going to be able to manage. I can't have this thing shaking when we're cutting that bore. So we're going to run whatever RPM we need to run for that. And I have metric gears in right now because I was cutting some metric thread, so I'm not really sure about the feed rate. So I'm going to have to experiment with that. We'll do that with the cutter way away here and see what we got. Pretty damn good, close rather. Let's go a little slower. Yeah, we're going the right way. Okay, I'm happy with that. What we'll do is we'll just do a touch off. Oh, you know what? I forgot, I gotta do something else, hang on. Yeah, the lathe was a little bit chilly, so I gave her a little wrap. I just do not want all these damn cast iron powdery chips going everywhere. I got a block down in the gully there, so the towel can't migrate up. This should be fine, I'll just keep my eye on it. Can always hit the E-stop if something happens, but all right, touch off. Good. I think all we're going to do is take 5 thou. Give it a shot. What's the worst that can happen? I got my hand on the E-stop and my other hand somewhere else. All right, I'm going to take advantage of these these alignment grooves here, because that's in between another section of the cut, and I'm going to go down to 270 because our surface feet per minute is going to be much greater as we go out as far as the radius goes. So let's try that. I want to see how that works because I'm fearing that we'll start getting some chatter at that speed out here. And you know what? We'll bump the feet up a wee bit to compensate. What you're hearing is the interrupted cuts from the slots. Nothing to write home to Mom about, that's for sure. We'll have to polish that in a little bit. All right. Oh man, that absolutely is gorgeous. I'm going to off-camera mark a 0 at the 0 mark on the spindle. So this thing will go back the same way. Eventually we'll get to the point where we can balance this thing, but I'm not going to worry about it now. Now if I did my job right, which there's a high probability I did not, I cannot do this with a board here. I wanted to for protection purposes, but this thing has got a very large swing. Swing! Swing, 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 swing! This one has a T-nut that comes through the back like this. Ta-da! Then you just put a nut on it. Wherever that went, I have no idea. And when my plane, I'm not gonna cinch it right now. I'm just gonna bring it up. I'm gonna bring it up. But I'm gonna put like a copper washer behind there just to protect the aluminum. We can't get much of an accurate reference on this old oil slinger spot here, but we can get it close enough to start boring it out. It's strangely satisfying, I don't know why. Okay, so this is promising. I can get in there with my Brown and Sharp. I can't do the sweep with it, but I can certainly do concentricity. I can get that inner bore. It's really rough because of that surface in there. But I bumped this around, no problem. There's a low spot in there, but for the most part. And again, I'm just trying to make sure that I can actually move this around. There's enough slop basically. There's enough room in these holes for it to move around. You know, kind of like a true center chuck, like Max Grant's doing a couple of those, where you actually leave the register on the back side of the chuck a little bit big, and then you got bolts that bolt the chuck to the backing plate, and you can move it around and then lock it in place. That's kind of the idea. That's where I got the idea for this concept from, was to be like, why couldn't I do it like one of those chucks on a backing plate? So I'm confident now that we can get this dialed in as close as possible that the bore will allow. Well, it's generally concentric here, so I'm good with that to start cutting it at least, because I want to see how this is going to cut. I don't know what this material is or anything. You know, the only purpose for this one here is just to keep, because everything else is on that side, just keep it square, you know. It's not doing anything else. And I do have a copper washer behind it. Yeah, there we go. That's good enough. I don't want to distort it, you know. Okay, so the big bore on the inside is 1.376. That little slinger bore is 0.885. Subtract the 2 divided by 2, and then you get 0.245 per side. All right, let's pick a speed. We know this thing wobbles like, well, let's see how bad it wobbles with the part on it. Let's start at 270. I'm going to do some experimentation here. Make sure we're clear. We are. Let's see what happens. It's pretty smooth. Let's go to 360. I don't know if I want to run this that fast, but yeah, we got a little bouncy here. Shit, I don't know if I can bore this out at that slow of an RPM though. Bump her up to 600 just for a second. Just a tip and just for a second. I don't think this is going to work, but oh no. Oh no, 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 no. This thing's way out of balance. I hope I didn't throw the part off. No, I don't think so. This thing's pretty tight. Oh no, not even close. All right, we're touching off there. Set the X. We'll go 20. I don't know what this shit is. We may luck out. Try that. Okay. 40. I just can't, unfortunately, I can't run any faster. This will be 80. Uh-huh. I think this is pretty hard stuff. If we don't get any chatter, then I think we'll be okay. We got a long way to go. And a short time to get there. Okay, with that much clearance now, boring that out to where we did, I can get my best test. Of course, the phone rings. I can reach all the way into the end of that bore in this configuration and setup with this best test is Brown and Sharp, and this is a tense indicator. Let's do the what do you call it, the concentricity first. Bumped it around a little bit more. You know, this bore unfortunately is rough, so we got to go in different spots. You go in a little further though, like this, and we are within, well, it's almost dead nuts. It's just bouncing around less than a half a thou. Let me zero that out better. I mean, that's pretty much 0, 0, concentricity wise. Now, here's the beauty part of it. Let's come all the way back, but we'll go ahead and sweep inwards. And right to the end of that bore, we're talking less than a half a thou. We're good right where we're at. So this surface back here apparently was machined with this as a reference surface. So I'm absolutely happy with this. I am not going to change a damn thing. I mean, we're only going in as far as we need to, but it's still really good practice just to make sure we are as concentric as we can possibly be. Okie doke. This bore is at 1.300 on the nose. And we have the inner bore we know is 1.376. Let's go 36 thou on a side, and then we'll blue it up, and then we'll do that. I'm gonna go like 10 thou at a time. 10. Trying to figure out inside there is it's almost like this is this two piece at one time? There's like a seam on the inside there. See that line down the inside there? Like these were actually two pieces. Anyway, we're just gonna keep going because I don't know what the answer to that is. That was 10. Let's do another 10 thou. A total of 20. Good. And then we'll go to 30. Beautiful. Okay, I am going to blue this up. We know we're 38 thou away, and right now we're at 30. We got 8 thou. I got it blued up. I got to be able to see this. When I'm getting really close to a finished cut, we're going to be just hopefully breathing on that dicum inside that edge. Yep. Perfect. Well, I got your light on too, so it kind of helps me out. Thanks for doing that. Plus we'll have this guy. Okay, I'm not contacting anything on that inner bore yet. I need to remeasure this because I can feel we got a little ways to go. Based on the math, I must have got a bad measurement on it. We should be there. Okay, I measured that wrong, but luckily on the small side because we got 20 thou to go, and that makes sense. I can feel that kind of a 10 thou step on it. That's 10 thou right there. Yep, we're clearing. Those numbers are right. I just don't want to blow this. I don't blow anything. As far as you know. Yep, okay. I'm just going to keep whittling away at it a little bit, a couple, maybe half thou at a time. I gotta be honest with you here. I don't know what's happening because I'm measuring this 3 times, dividing it by 2 because my DRO reads on the radius. And I still can't figure out why I can't get up to this depth. And I'm at depth according to the DRO. I don't understand this. Okay, I did the rest of this off camera, but we are exactly there and it came out great. So I'm going to measure this back up for you. I honestly don't know what was going on. I was doing the math correctly. I measure diameter-wise, but my DRO reads on the radius, just the way it is. Can't figure out how to change that. I don't think you can. So when you put this in this, and you measure this, like this, 377, maybe 377 and a half. And that inside bore is 378. That's what he wanted. He wanted it within about a half thou. One of my spring gauges is a little bit temperamental and it may have been expanding when I pulled it out of the bore, and that would give me a false larger diameter, therefore I wouldn't take off as much, but I don't think so because I double checked it after that.
I'm not sure what these lines are. They're nothing I did. It looks like either this is a 2-piece part of the casting, or maybe that's when they bored it out originally from the inside, and those are just tool marks.
I'm gonna set up a 45-degree tool on this and chamfer that just lightly. Off camera, I will work on the other one. May not be today, it might be another day. Get it up to the same stage. There's no problem in re-indicating these things in. If it comes up true again, this is going to be clocked on the backing plate exactly the same way. I'm not going to take the backing plate out till this job is done, but I ordered a 41 thou wide grooving tool from McMaster Carr that's carbide. That's absolutely going to hate this interrupted cut, but I'm going to try it and see what happens. Anyway, we'll see you back then, and so far so good. Okay, so it's the next day, and I did workpiece number 2 yesterday afternoon, and I did make a mistake on it that I'm going to show you, because again, I share my mistakes on this channel. This little line right here is not supposed to be there. Something that troubled me greatly. What happened was I was taking a final boring pass, and you know, it's hard to see in there even with a light. I was in with the boring tool. Something sounded weird because it seems to be like this is 2 different pieces. And when it hit that spot, I thought it was cutting into the main bore, which I can't have it do. And I kind of panicked, and muscle memory took over. And since I'm so used to turning, instead of rapidly moving the cross slide inward to clear the bore, I pulled it outwards because, again, muscle memory, and I ended up grinding a groove, cutting a groove right here. And I said, oh no. Well, this size here on the outside that I was cutting this final size on is exactly the same as this. It was perfect. So I called the boss man down, since he lives right down the road, around the corner, his shop, his house, and he said, that's not going to be a problem. He said, because the seal is rather wide, depending on where we put the snap ring groove, he wants it as close to the outer edge here as possible. Let me see if I can get you in and maybe angle you downwards a little bit more so you can kind of see this better. But the snap ring groove has got, now I don't have any room for my hand. The snap ring groove is going to be very close to the outside here. We discussed some dimensions, and he said as close as possible. So I said, well, if I went the width of the snap ring groove, would that be acceptable? He said yes. I got a 41 thou cutter coming for a snap ring groove, and this is like 39, so we're going to move it in 40 from the face here, which is just about in this area right here. So he said it's not going to be a problem because the seal's going to span that, and he uses some sort of sealant on it anyway, on these seals. Remember, this is a modification, so there's nothing real, there's no real, guidance factory-wise, since we're simply duplicating, or on this piece, the one from the 46. So that unfortunately happened, but it's recoverable because it's not going to scrap the part. I originally said if we touch this inside bore and do some naughty stuff, it would scrap the part, but that's not true. Not if I was further in, then we'd have a problem. Or if I did it out here, where the actual snap ring groove has got to go, we'd have a problem. But right there, it actually is okay. So we're just going to leave it, and I left this set up, because no reason to take it out, because I'm expecting that tool hopefully sometime later this morning via UPS. So this brings up the problem we have with cutting an internal snap ring groove with an interrupted cut and a very sharp edge here. So I've been thinking about this, and I'm going to go over my plan with you, and I think it's going to work. All right, so my idea was we're going to go ahead and treat the snap ring groove cutter, we'll just call it the cutter. We would treat a parting tool, and what I've been doing lately is I've been parting with the tool upside down and in reverse. On any lathe that isn't like super high precision and super high rigidity, you certainly have a little bit of play in this cross slide, especially these Chinese lathes. And you have a little backlash in the lead screw on the cross slide, just like you have backlash pretty much on any lead screw. Now, I have tightened this up as much as I can. It's only like, if I move the dial back and forth, it's only like 2 thou. So it's actually pretty good. The problem with parting tools, let me pull one out here, flip it upside down so you see it like it normally would be used. Problem with parting tools, no matter which ones they are, when they go in and you're turning it in a counterclockwise rotation like you normally would, so in other words, conventionally turning the spindle, I got gas. They have a tendency to go in, and of course the tool pressure wants to push them down. And if they dig in, what happens is, because you have a certain amount of positive rake on these, you have to have a little positive rake, obviously, positive cutting angle on the top here. Not only pull it down, but it'll pull it in when it jams up. And that's how you break these tools. Break your tool, or you damage the part, or both. Usually you just break a tool and change it out and go about your business, but that's why a lot of guys are doing it this way, and I'm doing it this way myself now, is putting it in this way. So when you put it in this way and you're reversing the lathe and it's turning the other way, so now we're turning clockwise, you're still advancing in this way. But what happens is, instead of, if it grabs, instead of it wanting to pull in, it wants to push it back. It wants to do this, like a horse. That's why these things hold up a lot better when we go in reverse. And that's why a lot of guys do it this way, and that's why I'm doing these parting tools this way, and I haven't had any problems with it doing, as far as breaking tips, doing it in reverse and upside down. And I think because of our interrupted cut up there, we're going to have a better shot at not breaking the tool or digging in or damaging that with it in this configuration. So when we push it in, let me get you up closer to the part again. So I'll try not to confuse you on this one here because it can be a little confusing. So again, when we have a parting tool and we have it upside down and we're coming in from this side, so left into right, like we normally would with the cross slide, we are going to be going in reverse. As I said before, we're going to be going this way, and then it doesn't tend to want to suck it in. It'll want to push it out and push it away. Well, since we're cutting on this side, or an internal side, we're going to end up having to turn it the correct way. In other words, counterclockwise, a conventional rotation of the spindle with the tool upside down, but on the back side. It doesn't make any sense to cut it in reverse on the front side because I can't see it. And it's really not going to help us at all. If we're cutting it this way on the inside, and it tends to want to grab one of these, it will still want to push it away and up instead of sucking it in and down, because we are cutting it this way. We're achieving the same tool forces, in other words, of an upside down parting tool if it was cutting a piece of stock, for example, from this side in, because we're turning it conventionally and the tool is upside down and we're working on this back edge. As I said before, the added benefit is I can see it, because it's really hard to see in here as opposed to over here. So that's why I think I'm going to try, and once we get the tool, we'll set it up on correct tool height, which I'm not entirely sure about if I'm going to run this a little high or low. I have to think about this, because here is the problem. These are 3/4, or well, maybe not 3/4, maybe 60% of the actual hole. So you have a small amount of that hole radius that is this spot right here. In other words, it's not even. So you have an edge that comes up on both of these because it's, you know, part of the hole, is part of the radius of this hole is still present. And that is a real recipe for a tool grabbing, because it's upwards a little bit. So if you're directly at center height on the spindle, you have a slight upward projection of this edge as this thing comes around. Even cutting on the backside in a conventional rotation like this. If you have some positive, I haven't seen the tool yet, but if you have I don't know how much positive rake is on that tool, but if you have a lot of it, then it's going to want to grab that sumbitch like crazy. So I'm figuring there's probably, you know, some positive rake on there. I don't want to modify that. I can grind carbide, but if I don't have a tool cutter grinder, so I have to do it freehand and easy to chip the tool and break it, so I'm not going to be able to touch it. We're going to have to use it as is. And I have to factor this in. Just not sure either raising the tool height or lowering the tool height will either help us or hurt us. I think if I was to do anything, I would try raising the tool height a little bit, because then this would come around a little bit more before the tool would engage this little spot. And this would be more level. In other words, it wouldn't be an aggressive radius upwards if I was running it at or on center or even below. With a boring tool, you actually want to run them a little bit below center to compensate for the tool flexion, you know, the tool flexing. So it essentially, if you're boring, you know, in a conventional rotation like we were doing, you were taking some cuts, what it'll want to do is it'll want to push the tool down with just from the tool load, and of course it depends on your stick out. So you raise the center just a little bit and it compensates for that. So once it starts taking a cut, it's dead center. But in our case, with an internal snap ring groove, I'm thinking we're going to try it first, running it slightly high of center. I just wanted to go over that because if we have a big fail, then, you know, I think it's going to fail either way if it's going to fail. If it's going to fail either way because of this lip right here, and it's an interrupted cut. Now I calculated the depth on the radius on one side that we need to go in with the tool. It's only 26 thou. And hopefully if we have a problem, is going to again want to kick it up and back instead of, you know, digging in and breaking it or damaging this spot right here. I don't have a terribly good feeling about this, but we're gonna give it our best shot. So when we get the tool in, I'll show it to you, and then we'll set it up and see what we can do as far as making a snap ring groove. So we'll see you then. Okay, here's a tool. It just came in from UPS, from McMaster-Carr. I got it mounted in this tool holder in the correct orientation. So there is the cutting edge. And it looks fairly neutral, which is nice. It is a round tool, but it's got a flat, and since we're putting it upside down, the flat goes nicely on my little shim here, so we can dial in the height easier. And I would have gotten a longer tool. I mean, I always like to have a longer tool, but in this case, their extended reach tools do not go down to this narrow of a dimension. It's supposed to be a 41. I measure it at 39. That's not as critical as the depth, I think, but because, you know, it'll work. It's only holding the seal in, there's no pressure behind it. Okay, so here's the plan. I'm going to set the center height. My height gauge here that just sits down on the cross slide is already set to the live center, so I'm just going to do that real quick. All right, so everything's clear because I had to reset the compound because otherwise I can't really reach it, and I pushed the compound all the way in, and then, well, I couldn't really reach it without hitting something, you know, without this part interfering with the carriage. So once I did all that and I got the tool all squared off, and you already saw the height, so we're ready to go here. Went ahead and did the tool offset with a 2 thou shim. So I know where I'm at on, and the DRO is zeroed there. That's close enough. Now what we need to do is we need to come to 0, come in 40 thou from 0. That'll bring us to the inside of the tool. Okay, so there's 40. We'll re-zero. Now we're on the inside edge of the tool. We're going to put the snap ring 40 thousandths in. That's all we got. May be able to go a little further to the outside. Yeah, I think we can. This is what I'm going to do to touch off. I'm actually going to just bring the tool in on the cross slide. Just turn the spindle by hand, see where it hits. I think we're going to have to do 35. Like I kind of originally thought. That's where I'm at right now. I blued it up. I got to make sure this is right. All right, I'm going to run this at 200 RPM. We're at 10 thou now. 22 thou. 3, 4, 5, 26. It should be our depth of cut right there. I'm going to have to measure that with the calipers though. All right, the snap ring is in place. I left this one edge out here, so it's no drama getting it back out because it ain't the kind that's got the little holes for, you know, for a snap ring plier. But that feels good. Now he's going to be putting new snap rings in anyway, so it appears that this is probably, from what I measure with this little, I found this little washer or something, and it's 40 thou wide. And it goes inside there with a slight amount of play. So this is probably 40.5 or 41, which is right where I wanted it. Because, you know, there's some variances in snap ring. This is the old one. And you can wiggle it back and forth just a wee bit. But, you know, like I said, the new snap ring is going to probably fit better. But that's all I had to work with. And that's the right depth. The calipers are exactly the same feel on this snap ring groove as they are on that 46. So, yeah, I'd say we're okay with this. We're doing pretty well. If I can get this out without damaging anything, that'd be beautiful. Okay, perfect. Okay, so we're done. All is well that ends well. Even with my faux pas, that mistake in there on the, what was it, the second one. But it's going to work out okay because I think where that circlip is now located, I think he's going to be real happy with that. I'm going to go deliver him now, see what he says. And if everything's good there, then we'll move on to something else. If you want to see some more crap like this, you know what you need to do. Like, share, subscribe, ring the bell, stick around. You see more junk, and I got some junk coming up, trust me. So as always, thanks for watching. Don't just repair, restore. We'll catch you on next video.